what if I told you that 87% of pickup trucks never make it past 250,000 miles without major repairs? Yet some quietly cross 500,000 miles with the original engine and transmission still intact. And no, it isn't luck. It isn't brand magic. And it isn't because they were built better. Pickups don't fail because they get old. They fail because of small habits that feel harmless. Until one day, they aren't. The real killers of pickup trucks aren't mileage or age. They're heat, neglected fluids, and habits most owners repeat every single day without realizing the damage. Today, I'm breaking down 13 mechanic-approved habits that can make your pickup last over 500K miles without living at the repair shop. And whatever you do, don't skip habit number 5, because it's the one that prevents one of the most expensive failures on any truck you can own. Let's dive in. Habit number 13, the 5K oil rule. Why pickups destroy oil faster. Most pickup owners trust long oil intervals because the manual says they can. 10,000 miles sounds reasonable. Modern engines, modern oil, modern engineering. But what the manual doesn't account for is how pickup trucks actually live. Pickups idle more. They tow more. They carry weight. They run hotter, longer, and underload far more often than passenger cars. And oil doesn't fail because of mileage. It fails because of heat and contamination. Every time oil is exposed to high temperatures, its molecular structure breaks down, viscosity drops, additives get consumed, and the oil film that separates metal from metal becomes thinner. Independent oil analysis data shows that in trucks used for towing or frequent idling, oil can lose 30 to 40% of its protective capacity long before the 10,000-mile mark. That's when timing chains stretch. Cam lobes start polishing instead of gliding, and microscopic wear begins long before you hear noise. The pickups that cross 400 and 500,000 miles almost always follow the same boring rule: shorter oil intervals, consistently. Not because they're obsessive, but because fresh oil is the cheapest way to slow down every form of internal engine wear at once. And if that sounds simple, good. Because the next habit protects a system that's far less forgiving than an engine. Habit number 12, transmission. Fluid and the heat problem. Transmissions almost never fail suddenly. They die slowly, quietly, and expensively. Pickup transmissions live in a constant battle with heat. Every gear change creates friction. Every heavy load increases hydraulic pressure. Every degree of excess heat shortens fluid life. Here's the part most owners never hear. Automatic transmission fluid starts breaking down rapidly above 200 degrees Fahrenheit, and for every 20-degree increase, the fluid's lifespan is effectively cut in half. Towing, stop-and-go traffic, and highway grades push pickup transmissions into that danger zone regularly. Once the fluid degrades, it can no longer cool the clutch packs. It can no longer maintain proper hydraulic pressure, and internal slip begins. By the time a driver feels rough shifts or delayed engagement, the damage is already internal. That's why mechanics don't wait for symptoms. High-mileage pickups that survive treat transmission fluid like preventative insurance, regular drain and fill service, before the fluid smells burnt, before the shifts change. Because once clutch material starts wearing away, no software update and no additive will bring it back. And the next habit protects a part that almost never warns you before it fails. Habit number 11, differential fluid and metal on metal. Wear differentials don't have warning lights. They don't throw codes. They just keep working until they don't. Every time your pickup moves, the differential gears are under constant load. Torque enters through the drive shaft and gets redirected through a set of gears designed to survive massive force. That survival depends entirely on one thing: a stable oil film between gear teeth. Differential fluid doesn't just lubricate, it absorbs shock, it dissipates heat, and it prevents direct metal-to-metal contact under extreme pressure. When that fluid breaks down, gear teeth start polishing each other instead of gliding. Microscopic pitting forms. And once pitting starts, it never reverses. Pickups that tow, haul, or run long highway miles cook differential fluid far faster than most owners expect. Mechanics see this pattern constantly. Strong engine, healthy transmission, but a howling rear end because the fluid was never changed. And by the time you hear that howl, the gear surfaces are already damaged. The trucks that last belong to owners who service the parts nobody talks about. Because in a pickup, the quiet components are often the ones doing the hardest work. And the next habit explains why some engines wear out faster every single morning. Trick number 10, why idling and bad warm-up routines. Kill pickup engines. Cold starts don't destroy engines. Cold idling does. For decades, drivers believed the safest thing to do was to let the engine sit and idle until it warms up. That advice made sense in the 1970s. It does not apply to modern pickup engines. Here's why. When a cold engine idles for extended periods, fuel doesn't burn efficiently. Excess fuel washes down the cylinder walls, diluting the oil film that protects the pistons and rings. At the same time, oil pressure is low and the engine is running rich. The result is accelerated wear at the exact moment when metal parts are most vulnerable. Studies from the U.S. Department of Energy show that prolonged idling can increase engine wear by up to 60% compared to gentle driving after startup. Pickups are especially affected because they often idle longer. Job sites, cold mornings, waiting, warming up before towing. The trucks that last don't sit and idle endlessly. They start, they stabilize oil pressure, and within 20 to 30 seconds, they move. Gently, light throttle, low RPM, no load. That allows oil to circulate properly and brings the engine up to operating temperature faster with less wear, not more. And once you understand warm-up physics, you're ready for the habit that destroys engines silently from the inside. Trick number 9. Coolant, heat cycling, and why. Head gaskets fail engine overheating is rarely sudden. It's almost always the final stage of a cooling system that's been degrading quietly for years. Coolant doesn't just keep temperatures down. It prevents corrosion, it stabilizes thermal expansion, and it protects aluminum surfaces from chemical attack. Over time, coolant becomes acidic. Its corrosion inhibitors get consumed, and once that happens, internal damage begins. Studies published in automotive engineering journals show that neglected coolant increases the risk of head gasket failure by nearly 40%, long before any warning lights appear. Pickups are especially vulnerable because they run hotter under load. Towing, hauling, climbing grades, sitting in traffic. A cooling system that looks fine from the outside can be actively eating itself from the inside. Tiny leaks form at hose connections. Water pump seals weaken. Radiators lose efficiency, and when coolant flow drops even slightly, localized hot spots form around the cylinder head. That's when aluminum warps, and once it warps, the gasket never truly seals again. High-mileage pickups that survive don't wait for overheating. They refresh coolant regularly. They inspect hoses and clamps, and they treat cooling maintenance as insurance against catastrophic failure. Because the next habit protects a component most drivers don't even realize is under stress every time they drive. Trick number 8, the fuel pump heat trap. Why running low costs thousands? Most drivers think of the fuel pump as a simple part. In reality, It's an electric motor submerged in one of the harshest environments in the vehicle. Fuel pumps rely on gasoline itself for cooling. When fuel levels drop too low, the pump loses its thermal buffer, temperatures rise, electrical resistance increases, and wear accelerates. Industry teardown studies show that fuel pumps operating repeatedly below a quarter tank can run up to 40 degrees Fahrenheit hotter than pumps that stay submerged. Heat shortens motor life dramatically. At the same time, running low pulls sediment from the bottom of the tank into the fuel system. Fine particles that stress injectors and restrict flow. The failure doesn't happen immediately. The pump weakens slowly, starts become longer, acceleration feels slightly flatter. Until one day, the truck simply doesn't start. High-mileage pickups avoid this entirely with one simple habit. They don't live below a quarter tank, not because they're paranoid, but because fuel pump replacement is one of the most unnecessary failures mechanics see on otherwise healthy trucks. And the next habit explains why some pickups eat electrical components while others never seem to have SIXCUM mystery problems. Trick number 7, electrical grounds and the mystery failure. Problem: most pickup owners blame electronics when things start acting strange. Random warning lights, hard starts, rough idle, erratic transmission behavior. What most drivers never realize is that many of these electronic failures aren't electronic at all. They're electrical. A pickup's entire electrical system depends on a small number of ground connections: battery terminals, engine block grounds, chassis grounds. As these connections corrode or loosen over time, voltage becomes unstable. Sensors receive inconsistent signals. Control modules misinterpret data, and the truck starts behaving like it has multiple failing components. ASE technicians consistently report that nearly 1/3 of mystery electrical problems are traced back to poor grounds, not failed parts. That's how owners end up replacing alternators, sensors, and control modules that were never bad in the first place. High-mileage pickups avoid this spiral with a habit that takes minutes: clean terminals, tight connections, stable voltage. Because when voltage stays clean, electronics last longer and problems don't multiply. And the next habit explains why so many transmissions die even when the fluid has been serviced. Trick number 6, towing habits that quietly destroy transmissions. Most transmission failures aren't caused by bad parts. They're caused by bad habits under load. Pickups are designed to tow, but they're not designed to be abused while doing it. Towing at low RPM under heavy throttle creates extreme heat and pressure inside the transmission. Gear hunting, late downshifts, constant torquey converter slip. All of it raises internal temperatures far beyond what the fluid was designed to handle. This is why manufacturers include tow, shoe, haul modes, not for convenience, but to protect the transmission. Tow haul raises shift points, reduces gear hunting, and locks the torquey converter sooner. High-mileage towing trucks don't rush climbs. They let RPM rise. They accept downshifts. Because lugging a transmission under load is one of the fastest ways to cook fluid and clutches at the same time. And when transmissions fail under towing conditions, the damage is rarely isolated. Heat spreads, seals harden. Clutch packs glaze. That's why towing failures are often total rebuilds. And the next habit is the one mechanics see right before engines and turbos fail. Trick number 5, engine lugging and internal stress. The most expensive mistake. Lugging feels gentle, low RPM, light throttle movement, quiet operation. But mechanically, lugging is one of the harshest conditions an engine can experience. When an engine is under heavy load at low RPM, cylinder pressure spikes dramatically. That pressure transfers directly to rod bearings, main bearings, crank journals, and turbocharger components in boosted engines. Instead of smooth rotational force, the engine experiences hammer-like stress. This is why engines that are constantly lugged develop bearing wear, oil pressure issues, and in turbocharged pickups, early turbo failures. Engineers design engines to work within a torque band. Below that band, the engine isn't relaxed, it's struggling. High-mileage pickup owners understand this instinctively. They downshift earlier. They let the engine breathe. They don't force the truck to climb hills in gears it doesn't want. Because engines don't fail from revving moderately. They fail from sustained stress at the wrong RPM. And once bearing damage starts, no oil change can reverse it. The next habit explains why some pickups rot away long before their engines ever wear out. Trick. Number 4. Frame rust, metal fatigue, and why pickups become unsafe. Most pickup trucks don't fail because the engine gives up. They fail because the structure underneath them does. Frames don't rust evenly. They rust from the inside out. Moisture enters through drain holes, seams, and weld points. Road salt accelerates the process by creating an electrolyte that speeds up oxidation. And once corrosion starts inside boxed frame sections, it spreads where you can't see it. Every heat cycle weakens the metal slightly more. Every winter accelerates the damage. Engineering studies on structural corrosion show that frame steel can lose up to 30% of its load-bearing strength long before visible holes appear. That's why mechanics see this scenario constantly. The engine runs perfectly, the transmission shifts fine, but suspension mounts start tearing away, brake lines burst, and suddenly the truck is unsafe to drive. High-mileage pickups that survive long-term aren't just mechanically maintained. They're structurally protected. Owners wash the undercarriage. They inspect brake and fuel lines. They stop corrosion early before metal fatigue sets in. Because once rust compromises the frame, the truck isn't worn out, it's finished. And the next habit focuses on something far smaller, but just as damaging over time. Habit number 3, airflow restriction and internal engine strain. Engines don't fail only from friction, they fail from imbalance. A restricted air intake forces the engine to work harder just to breathe. As airflow drops, intake vacuum rises. Fuel trims adjust. Combustion temperatures increase. In direct injection engines, this imbalance accelerates carbon buildup on intake valves because fuel never washes them clean. SAE studies show that airflow restriction combined with carbon buildup can reduce volumetric efficiency by 8 to 12% without triggering a single fault code. That loss doesn't just affect power. It increases piston temperatures, raises exhaust gas temperatures, and places additional thermal stress on valves and turbochargers. Mechanics recognize this immediately. Trucks come in with no codes complaints. Sluggish throttle, poor MPG, rough idle, and the root cause is almost always airflow degradation that went unchecked for years. High-mileage pickups don't wait for symptoms. They replace filters early, they keep the intake path clean, and when carbon buildup starts affecting combustion, they address it before heat becomes destructive. Because engines that can breathe properly run cooler, cleaner, and last dramatically longer. And the next habit explains why heavy pickups destroy brakes and everything connected to them. Habit number 2, braking heat, thermal shock, and front-end failure. Brakes don't fail from wear alone. They fail from heat overload. Every hard stop converts kinetic energy into thermal energy. On heavy pickups, that energy spike is massive. Late braking can push rotor temperatures past 500 to 700 degrees Fahrenheit in a matter of seconds. At those temperatures, metal expands rapidly, pads glaze, rotors warp, but the damage doesn't stop there. That heat transfers into wheel bearings, ball joints, bushings, and suspension mounting points. Repeated thermal shock weakens grease, hardens rubber, and accelerates metal fatigue. This is why some pickups need front-end rebuilds at 150,000 miles, while others feel tight at 300,000. The difference isn't parts quality, it's heat management. High-mileage truck owners don't rush stops. They lift early. They let engine braking share the load. Lower peak temperatures mean longer brake life, stable suspension geometry, and fewer vibration-related failures. It's a habit that costs nothing and protects multiple systems at once. And once you understand heat, you're ready for the final habit, the one that ties every other habit together. And number 1. And first of all, consistency is the real reason 500,000-mile pickups exist. There is no secret part, no magic additive, no legendary engine that survives abuse. Every pickup that crosses 500,000 miles shares the same trait: consistency, not perfection, consistency. High-mileage trucks aren't owned by people who fix things when they break. They're owned by people who prevent wear before it becomes damage. They don't wait for warning lights. They don't stretch intervals, just this once. They don't ignore small symptoms hoping they disappear. They understand something most owners don't. Mechanical failure is rarely sudden. It's cumulative. Oil breaks down gradually. Heat stress builds cycle by cycle. Corrosion starts microscopic. Electrical resistance increases one connection at a time. By the time a failure announces itself, the damage is already months, sometimes years, old. That's why high-mileage pickups feel different. They start clean, they idle smoothly, they shift without hesitation. They don't rattle, vibrate, or feel tired, not because they're newer, but because nothing inside them was ever allowed to spiral out of control. This is the difference between a truck that runs at 300,000 miles and a truck that still works at 500,000. And it has nothing to do with luck. It has everything to do with habits repeated quietly long before problems appear. Most pickup trucks don't fail because they were built poorly. They fail because small mistakes were repeated for too long. The trucks that survive 500,000 miles aren't owned by experts. They're owned by people who respect the machine. They understand heat. They respect fluids. They listen before parts start screaming. And once you cross that 500,000-mile line, something changes. You're no longer driving transportation. You're driving proof that discipline beats design. Now, I want to hear from you. What pickup are you driving? And how many miles are on it right now? Which one of these habits are you fixing first? Drop it in the comments. If this video made you rethink how you treat your truck, hit like. Subscribe if you want more mechanic-level insight without the marketing nonsense. And don't miss the next video, the oil and maintenance myths that quietly kill pickup trucks long before they should. See you in the next one.